session. Today we're going to be continuing with this is the second part of the basics of Laplace inverse. Remember, when I talk about Laplace, you're just referring to an integral. When you talk about Laplace, we're talking about integral which move f of t to what? To f of s, which is frequency domain, and then this is time domain. So today we're gonna be continuing with our basics. So I'm going to continue from where we stopped last time. So as I have already explained that these are actually the basics, so I did not prepare none of this question. I'm just extracted them from slides. I will prepare my own for you when we actually write a test, and I think from next week, next week we're going to have test on Friday, Saturday and Sunday in preparation for the semester test. So as I have already explained, we're going to focus on rule 14, 15 and 16. So let's say, for example, you have you are required to determine the Laplace inverse of 12 all over s minus 4, s minus 2, which is raised to the exponent 4. Well, you can rewrite this as the inverse Laplace of 12 all over s minus 2, the exponent 3 plus 1 is the same as having 4 again. So from here we can actually see that the value of n, is equals to what? Is equals to 3, right? And then it means n factorial will be what? Will be 6. So, and you can see we're having a problem here. You ask yourself, what is that number which was multiplied by 6 which give us 12? It means we're having 6x. 6 multiplied by x number will give us 12 because of this 12 here. And then know x is going to be what? X is going to be 2, right? Okay, cool. So we can easily spot this, or this is rule number man, by looking at these whole rules here. Oh, I think I forgot to attach it. This is rule number 8. That says if you're having t to the exponent n e b t, and then you can represent it as n factorial all over s minus b to the exponent n plus 1. Understand? This is the rule that we're actually working with right now. So we can see already here we're having a number which was multiplied by the number. This 2 is the number which was multiplied by 6. That's why we're having 12 here, right? So how are we going to determine the Laplace inverse for this one? Determine the Laplace inverse, we realize this is rule number 8. It means we must have t to the exponent n. What is our n? Our n is 3, the exponent 3, and then e to the exponent b. What is our b? Our b is positive 2, so we're going to have 2t, and then this is how we solve the problem. Remember, we took into consideration this number which was multiplied, in fact, so we're going to balance the whole equation by 2 here. I hope it makes sense. Okay, to re-explain this, let me just erase this whole thing here. To re-explain this, I can say we're having the Laplace inverse of this whole thing here, right? So we need to take the Laplace inverse of this whole thing. How are we going to take the Laplace inverse of this whole thing? To take the Laplace inverse of this whole thing, we're going to use the table, right? So I said let's rewrite it in this format: the Laplace inverse of 12 over s minus 2, which is raised to the exponent 3 plus 1, which is the same as 4 again. So we can realize this is rule number 8 that says t to the exponent n e to the exponent bt. If you are moving from this format to this format, and then you're going to have something like this, right? So we can easily spot here where our n is what? N is equals to 3, and n factorial will be what? Will be 6. So I ask myself, well, what is that number which was multiplied by 6 so that we can have 12? So it means we're going to say 6x is equals to 12, and then we realize our 6 is equals to, x is equals to what? Is equals to 2. So that is why here we're having our 2, and we know if we're taking the Laplace inverse, we're moving from this part here to this whole thing here. We're going to use t, the exponent n, e, the exponent bt. So let's move to the second one. Let's say this is b. Let's say you're having y of s, which is equals to 1 all over s plus 3, which is all raised to the exponent 2. Okay, you need to pay attention here, guys. When you're moving from function of time, when you're taking Laplace, so when they say take the Laplace, when you're taking the Laplace, it means you're moving from function of small letters. It's very important, small letters to capital letters. But then when you're taking the inverse, it means we are moving from capital letter to what? To small letters. You understand? To small letters. This is for inverse, and then this is for taking the Laplace, and then this is the inverse Laplace. This is for Laplace using the table. So you can see here we're having y of s, which is equals to 1 over s plus 3, which is raised to the exponent 2. Because of this capital letter here, it means we are required to do what? To determine the Laplace inverse, not the Laplace. We are required to determine the Laplace inverse. Understand? So we can rewrite this as 1 over s plus 3, which is raised to 1 plus 1, right? And then we can see that n is equals to 1. N factorial would be equals to what? To 1, because if you say 1 factorial, it's still going to get 1, right? We're still going to use rule number 8. Rule number 8, which says if you're having t to the exponent n, e to the exponent bt, and then your answer will be n factorial all over s minus b, which is raised to n plus 1. So we can see we're already in this format. So we're taking the inverse. It means we're moving to the other side. So basically we know y of t will be what? We already know we're going to have t to the exponent n. What is our n? Is 1. We know t to the exponent 1 is the same as t. It's like having x. You can't say I'm having 1x. Understand? And then we have e to the exponent b, bt. Okay, you need to pay attention here. The formula says we're having n factorial all over s minus b. According to the formula, we're having a minus here. But if we come and look at this part, we're having a positive. It means how can we get positive? How did we end up with this positive if the formula said we're having s minus b, and here we're having s plus b? So this basically means we had minus 3, which was multiplied by, we had s minus into negative 3, which give us s plus 3. So this basically means our exponent here for e is going to be minus 3t. Hope it makes sense, okay? Minus 3t minus 3 minus 3t. This is how we actually supposed to solve it. And another thing which I want to talk about is this. We started with a capital letter, we took the Laplace inverse, and then we end up with the small letters from frequency domain here to our time domain. Yeah.